problems using base E, and we're going to focus on compound interest. This slide you want to write down in its entirety. Compound interest, imagine putting money into a bank account and it compounds interest over a number of years. The equation for per year, this is our formula that I do need you to memorize. A represents your end amount. When you're done with your savings account, what would you have left? P represents your principal, which is your initial amount. R represents your interest rate, and be careful that your interest rate has to be in decimal. So if you have something like 5% as a decimal, it's going to be 0.05. T represents the number of years. And then N, which is probably the hardest part for students to understand, is how many times does the bank compound the interest per year? And that's right here and right there. So make sure you write down these compounds below. If your N equals 365, that means every day the bank compounds your interest daily. If it's 52 times a year, that means it's compounded weekly. If it's 12 times a year, that's monthly. 4 times a year, it's quarterly. Semi-annual means 2 times a year, and annual means 1 time a year. So write those down, please, in your notes. The second part of the slide is if we tell you that the problem is continuous, you have to change up your formula then. That's where base E comes into play. Remember, base E is at approximately 2.71. We call this for short the PERT equation, because P-E raised to the RT. A is that same end amount when you're all done with your savings account or checking account, whatever it is that you're investing in, that's the money you have left. P is your initial amount, your principal. E is your natural base E, which is approximately 2.71. Your interest rate, again, remember it has to be in decimal form. And then your T is your time in years. So be careful that we give you like a half of a year, then you need to put in 0.5 for T. So let's go on to an example. Let's say we want to invest $13,000. So that's going to be your principal. And we want you to get an interest rate of 9%. So this is your R. But be careful, that's going to be R equals 0.09. We want to find out what is your balance after 5 years. This is going to be your time. And then we give you some different compound methods. So the first one is quarterly. So quarterly means 4 times a year. That's your N. So the formula we're going to use is this first equation. A equals P, 1 plus R over N, raised to the NT. And we're going to throw in the pieces into the equation. So our end amount is unknown. Our principal is $13,000. 1 plus R. R is 0.09. Over N, which was 4 times a year, N of 4 times a year, and then our T is 5 years. Now you have to do your PEMDAS rules, your orders of operation, so we have to do our parentheses first. So we'll go inside of here first. First take your fraction divided, 0.09, divided by 4, you get 0.0225, add 1, and this becomes 1.0225. And if your exponent, 4 times 5 is 20. And then I'm going to leave that 13,000 alone. All right. Now, either you can be comfortable with your graphing calculator, your scientific calculator, enter this in one shot, or take your time, leave that 13,000 alone for now and focus on the exponent. So 1.0225, raising that to the 20th power, and go out a pretty big amount of decimal places, 1.560509, and then go back and multiply that to 13,000. So 13,000 times 1.560509. We would rather you be a little bit more comfortable with your calculator and enter that in one shot, but if not, that's okay. So we're talking money, so our units is money, and when we talk money, we go to the nearest tenths or hundredths place. So there's our end amount, about $20,000. Now let's change it up to monthly. So monthly means that the bank is going to compound your interest 12 times a year. So your N now equals 12. We're going to use that same formula that we used above. Again, you have to memorize that formula. Our initial investment, $13,000. Our interest rate of 9%. But now it's compounded monthly, so our N is 12. And then it's 5 times because of 5 years. So let's simplify that. We do our parentheses first. Go to our fraction, 0.09 divided by 12 is 0.0075. Add 1, and you get 1.0075. Then multiply these two pieces together. 12 times 5 is 60. And then you have $13,000. All right, so let's this time try to put in our calculator in one shot. So take $13,000 times, put your parentheses in, 1.0075, finish that parentheses, raise it to the 60th power. And you should get $20,353.85. Our last part is now continuous. That's changing things up a lot. We're going to use the PERT equation. A equals PE to the RT. So our principal is $13,000. Our E is that E that we're going to use with our calculator. Our interest rate is 0.09, and our time is 5 years. So we're going to do our exponent piece first, 0.09 times 5. 0.09 times 5 is 0.45. Leave the E and the 13,000 alone for now. And now try and throw it in one shot. So 13,000 times E, 0.45, finish off the parentheses, and we get an amount of $20,388.06.